Hello students, this video is to help review the week 5 content. We talked about arcs of a circle during week 5, specifically how to measure them, how to measure their lengths, and also how to measure them in terms of degrees or radians. Remember that radians was sort of an optional topic, that was a little bonus. You are going to be having to do radians a lot, or work with radians a lot in Algebra 2. Let's take a look at the first question here. In that first question, it asks you to find the measure of arc BC. And in order to do that, you have to take a look at the diagram here and label it up, and I've labeled it for you. It tells us that the line segment EP is perpendicular to diameter AC, which means there's a right angle here. It also tells us that arc AB has a measure of 5x minus 24, which is labeled here, and 3x plus 10 for ED, that's labeled here. The first thing I want you to understand is that this is an example of a circle theorem question, which says that all arcs in a circle add up to 360 degrees. Similarly, all of the interior angles from the center, we call those central angles of a circle, add up to 360 degrees as well. So all we have to do is identify all the different arcs around the circle, set them equal to 360 degrees, and we are basically done with the problem. So let's make sure that we have all of these arcs. The first arc that I'm looking at here is 3x plus 10. I do know this arc, no big deal. The next arc that I can take a look at is this arc here, which is not labeled, but I know that this angle is a 90-degree angle because of perpendicular lines. Since this is a 90-degree angle, this arc must be 90 degrees because a central angle is equal to the arc that it cuts. The next arc that I'm looking at is this arc from A to B, which we were given, which is 5x minus 24. This next arc here, arc BC, that's the one we're looking for. So as you could probably guess, we don't have this one. And then last but not least, this arc down here, which is not given to us, arc CD. However, we can use the vertical angles theorem. Vertical angles theorem says that if two angles are created by two intersecting lines, then those two angles that are across from each other are congruent, which means this is 5x minus 24, so this must be 5x minus 24. So what I've done is I've just marked off all the arcs that I have identified just to make sure that I haven't missed any, and it looks like I've identified all of the arcs in this circle. So what I'm going to do is add them together and set them equal to 360 degrees. Okay, I've identified every arc around this circle and I've plugged them into the equation, but hopefully you can see by now that there's a small issue with this situation. Here's the issue. I have 3x plus 10 plus 90 plus 5x minus 24 plus BC plus 5x minus 24 equals 360. If I were to try to solve this question, I actually have two unknowns. I have the x, which is an unknown, and I have the BC, which is an unknown. So using the circle theorem will usually work as long as you have all of the arcs around the circle. Unfortunately, this missing arc BC is going to prevent us from using the entire circle theorem. Luckily, there is one part of this problem that allows us to do part of the circle theorem. That's this word, diameter. Remember that a diameter cuts a circle in half. It cuts the circle at its center, and it divides the circle into two halves, and each of those halves is equal to 180 degrees, or in other words, the angles on one side of that diameter are going to add up to 180 degrees, and the same thing down here. We're going to be able to use this in order to find the value of x, because once we cut the circle in half, we don't care about the arcs down here, we're only going to care about the arcs up here. This is a special application of the circle theorem, which should make sense to you because the diameter cuts the circle in half. Alright, hopefully I am able to highlight this a little bit to make this a little bit easier for you to see. I'm telling you that the diameter cuts the circle in half, which means that all of the angles on this half, or all the arcs on this half of the circle, are going to be equal to 180 degrees. Well, we have this arc, which we labeled as 3x plus 10, that's here. We have this arc, which we labeled as 90 degrees, which makes sense because this is a right angle, that's here. And we have this arc, which is 5x minus 24, which rounds the equation out here. And it's equal to 180, as I said, because half of the circle adds up to 180 degrees. Hopefully this makes sense to you. All we're doing is we're taking all of the calculations and trying to simplify them. An alternate way of solving this problem would be to find this angle using the arcs on the other side of the circle, but this is a more straightforward approach to solving the problem. So let's try it out. There should be no surprises from this step to this step because that's just algebra. Now we have x is equal to 13 and we're asked to find the measure of arc BC. So to finish out this problem, we are going to need to substitute in for arc BC. Unfortunately, we don't have arc BC, but there's an easier way to do this. I can figure out this arc, which is 5x minus 24, and then figure out what this arc is based on the same fact that the diameter cuts the circle in half. This whole thing has to be 180 degrees. which means if I subtract this arc out, I'm going to be able to get this pretty easily. So let's figure out what 5x minus 24 is. Again, simple algebra step here. I should figure out that arc CD is equal to 41 degrees pretty easily. Now all I need to do is find BC by taking 180 and subtracting 41 from it. And there you have it. Arc BC should be equal to 139 degrees. It's the remainder of that 180 degree arc when you take out this arc, which is 5x minus 24. Not too bad. For the next question, it tells us that it has the circumference of 24. This circle's total distance around is 24. We know that major arc LM, which is the longer arc, has a distance of, or a length of 22, and it asks for the measure of angle LAM in degrees. Well, one thing that we can figure out right away is that since major arc LM is 22 and the entire circumference is 24, that means that this arc LM here in units is going to be 2. So that is a 2-unit arc. However, that doesn't tell me the measurement of angle LAM in degrees. I can't say that this is 2 degrees. So what I have to do is use the formula that they told us about on Khan Academy. It's the formula that tells us the relationship between the circumference of a circle and the arc of a circle. Here it is. In case you didn't remember from the video, that proportion is that arc length divided by circumference is equal to the central angle divided by 360 degrees, which should make sense to you because this is the part of the circle, the arc length. The circumference is the entire circle. So now we're using that to figure out how much the central angle is, which is part of the inside of the circle, divided by 360 degrees, which is the total angle of the circle. Now let's substitute in the things that we know. All right, we took the 2, which is the arc length, and put it in the numerator here. The denominator is 24, which is the circumference. That should be equal to x, which is the central angle here, divided by 360 degrees, which is the total number of degrees in the outside arcs of the circle. All right, so crisscross applesauce here. This is an algebra problem, so I'm going to fast forward to the end. All right, we've solved for x here. And then the question is, what is the measure of angle LAM? So we have to put a little sentence that says the measure of angle LAM is equal to 30 degrees. Remember to include these units. That's an easy way to lose 1 point. All right, moving on to the next question, question number 3. Circle Q shown below has a circumference of just 80 degrees, actually, all the way around. And it tells us the measure of angle FQG is equal to 36 degrees. That's here. It asks us the length of arc FG, which is from here to here. And now be careful, it asks for length. We're not looking for the distance around the circle here in terms of degrees. We're looking in terms of inches. So there's a special way to calculate arc length, and it was in one of the Khan Academy videos. Here it is. And you might think to yourself, hey, this kind of looks familiar. Well, it should be familiar to you because it's the same exact formula that we used in the previous problem. Now the thing that we're looking for is not the central angle because we have that. We are looking for the arc length. So let's substitute in the things that we know. All right, and something that's pretty typical for geometry problems, the problem might seem a little daunting at first, but once you figure out which tool to use, just like with sine, cosine, and tangent, just like with other topics related to circles, once you figure out the correct tool to use, it actually becomes pretty trivial algebra. So we're going to crisscross applesauce here and find the correct answer. And like I said, a pretty trivial algebra problem. We cross multiplied and we found that FG is equal to 8. So in other words, the length of arc FG is equal to 8. However, we can't leave the problem like this because that's an easy way to lose 1 point. It tells us that the circumference of the circle is 80 inches. So that means the length of arc FG is equal to 8 inches. Remember, when we're talking about length of an arc, we're talking about inches or feet or yards or meters, centimeters, something like that. When we're talking about the measure of that arc in terms of degrees, that's what we're looking for. As a bonus, the radian measure of angle FQG in terms of pi, there's an easy way to do this. Here's a conversion factor. All right, you should know that in order to convert an angle from degrees into radians, we're going to multiply it by the constant 2 pi divided by 360. You might have also seen pi over 180 in the Khan Academy videos. He kind of switches back and forth sometimes, but this is probably the easiest one to remember. So we're multiplying the angle by 2 pi over 360. Here's what it looks like. All right, here's a quick lesson in multiplying fractions together, or a fraction by a whole number. We're taking the fraction and multiplying by a whole number, which means we multiply this whole number by the numerator. 36 times 2 is 72. The pi stays along for the ride. And then divide by 360 degrees. Excuse me. In my calculator, I did 72 divided by 360 degrees, and I got 0.2. 0.2 turned into a fraction by using math enter, turns into 1 over 5. The pi stays in the numerator, so 1 pi just turns into pi. Pi divided by 5 is the number of radians. That was not necessary for you to do, but you did get 1 bonus point if you did it. For question number 4, it asks for the length of major arc PQ. Now be careful because this is minor arc PQ here. Major arc PQ is going to be the arc all the way around the circle the long way. So careful with that. It tells you you can leave the answer in terms of pi or round to the nearest thousandth. I think I'm going to show you both. All right, so I've done some quick labeling here. You can tell that this angle is 60 degrees, this central angle, which means that this angle, which is the larger part of the circle or the rest of the circle, we call this the reflex angle. That's a good word to know for Algebra 2. That's 300 degrees. So this angle here is 60, this is 300, adding together, that's 360 degrees, which means the distance from here to here is going to be related to this central angle, which is 300 degrees. That means that goes here. The arc length is something that we don't know, that's something that we're looking for. However, the circumference is something we also don't know. We can't use an equation with 2 different unknowns, but luckily for us, we can figure out the circumference using the circumference formula, which is here. It should be easy enough for you to do the circumference formula. All you have to do is substitute in the value of r, and it tells us here that the radius is 9. So we're substituting that in. Careful here, sometimes students want to square r because the area of a circle is pi r squared. This is circumference, the distance around, so we don't need a square value. We just need a regular value. So 2 times 9 is 18 times pi. I'm not going to put this into my calculator because it says I'm allowed to leave my answer in terms of pi, and it's just easier to just bring the pi along for the ride rather than rounding in the middle of the problem, and then every single time I have to round. That's just a hassle. I'm not going to do it. All right, so let's substitute into this equation, now only having 1 unknown. All right, hopefully you see the value of not putting the pi symbol into your calculator. I crisscross applesauced here, and I got 300 times 18. That's 5,400. I'm just bringing the pi along for the ride. I'm not going to multiply the pi in the calculator because that gives me an irrational number, and that's a lot of numbers to keep track of. 360 times PQ, that's here. Then I'm going to divide both sides by 360. I'm just going to do 5,400 divided by 360. That's 15 in the calculator. I'm going to keep the pi here. 15 pi units is equal to PQ. So I'm done. I have my answer. My answer in terms of pi is 15 pi. If you had to, if you were desperate to round to the nearest thousandth for some reason, rounding to the nearest thousandth is going to give you 47.124 units. So that's the measure of major arc PQ. Last but not least, we're given that this circle has 2 diameters drawn, and it's asking for the measure of arc EDB. I've drawn you where arc EDB is. Just to be clear, arc EB would have been here. If I'm looking for EDB, it must be from E to B going through D. So we have one angle here, one central angle that's known. I'm going to label the circle with all of the other angles that we know. Okay, turns out we're able to get most of the answer from this, but we're not able to get all of it because of this. I have angle 63 degrees here, and I have an angle that's 63 degrees here because of these vertical angles. However, in order to get arc EDB in its entirety, I'm going to need to know this angle, which is from D to C. In order to do that, I'm going to, again, use that trick that we remember from problem number 1. As long as it tells us that there's a diameter there, it tells us that I can split the circle in half from here to here. And now I'm no longer dealing with 360 degrees, I'm dealing with 180 degrees. In other words, this angle is 63. Whatever this angle is adds to 63 to give us 180. All right, since we know that a diameter cuts a circle in half and all the arcs and the interior angles in half a circle add to 180 degrees, we can find angle DPC to be 117 degrees. Now all we have to do to find the measure of arc EDB is to add all of these arcs together. I'm going to show you how that looks right now. All right, we added 3 of the arcs together and we got 243 degrees. Just as a quick clarification, I've been talking about arcs and central angles pretty synonymously here because I know that if this arc is 63 degrees, this angle is 63 degrees, this arc is 63. If I know that this central angle is 117, then this arc is 117. Same thing with this angle and this arc. This was a review of the Week 5 quiz on arcs of a circle. Good luck studying.